Welcome to the test of two high-end air CPU coolers, Zalman CNPS20X and Noctua NH-D15 SE-AM4. In this test, I'll be asking 5 interesting questions. Is Zalman CNPS20X the best CPU cooler in the world, as it states on its box? Second, if I give both coolers the same thermal compound, that means if I normalize the conditions of the test, who's gonna be better and by how much? If I take everything what's inside this box as a solution and compare it to what's inside this box, who's better? I'll be comparing both thermals and noise. 4. If I take these fans and put them on this heatsink, is it going to improve its performance or worsen it? And the last question is, what really makes the best air CPU cooler to be the best? Well, if you want to know the answers to these questions, continue. Let's have a quick look at the individual setups. The first one is Zalman CNPS20X. As in all other setups, it has one fan raised above the memory modules. In this case, the RGB was on because that is how it's meant to be used. You can also notice the manual fan speed controller, which I used for all the setups. And now let's have a look at the Noctua. The Noctua NH-D15 SE-AM4 also has one fan raised. Both coolers do a good job at providing sufficient airflow to the passively cooled graphics card. So let's now have a look at the bonus setup. This is how the RPM of the fans was monitored. The attachment of the fans to the heatsink is made by wires. It is a quick punk style solution, yet it worked. I just did it out of curiosity. And here is a look at the hardware and software used for the testing. The most important are the frequencies and voltages of the CPU. For the testing, I had to normalize the frequencies to avoid any fluctuation. I finally settled at 4.1 GHz at 1.312 volts and 4.25 GHz at 1.35 volts because the system was stable at these settings. In your particular use case, you may have better or worse silicon, so you may have to increase the voltage or be able to lower it. Let me give you first tip here for speeding up the search for stable overclock. I tried all the tests in AIDA64 and found out that the most stability sensitive is FP64 ray trace test. To test if your OC is stable, first try this benchmark, which takes just a few seconds, and then try the other stability programs. Because if your current settings don't pass this one, you'll need to make some adjustments to the voltage or frequency, assuming you weren't fiddling with the memory settings or anything else, and you won't lose too much of your time. When we look into the BIOS, you can see that I created two profiles. Here is the 4.1 GHz profile. The only thing that changes between the profiles is the multiplier and the CPU vCore voltage. RAM was using a predefined XMP profile from the manufacturer, so for the 4.25 GHz OC, I used these settings. Now let's have a look at the fan speed which was used during all the tests. Why was the fan speed normalized? First, it has to be normalized to make sure that the conditions of the test don't change during the test. Second, I assume that people who buy high-end coolers buy them to avoid noise. Third, my personal noise threshold is 36.5 dB, but I know that other people can withstand more, so I set the acceptance level to 40 dB. I don't think anybody sane would run these coolers at full speed because every 100 RPM noticeably increases the noise. Also, keeping constant RPM of the fans is something I've been doing for the last 15 years because I can't stand sudden spikes of noise whenever I perform any CPU intensive task on my computer. So these are the reasons. As for the software, I used 3 most common benchmarks which are able to make use of all cores of the CPU and are also free for download. I added one non-standard, which is DaVinci Resolve, which I use for editing my videos. I chose it to show you how the temperatures look when using a real-life application and not a synthetic benchmark. However, because this isn't verifiable by anyone else and too many variables are present, its results are excluded from the conclusion of the whole test, and therefore it serves only for informational purposes. Now these are the test conditions. You can pause the video and read them. I'm going to address just one of them, and that is what I call the baking time, which goes for baking the thermal compound into the heatsink of the cooler and the surface of the CPU, or in other words, partially solidifying. It has great impact on the temperatures and can cause difference ranging from 3 to 10 degrees Celsius depending on the test. I ran all the tests the day before the testing and let it cool down for 9 hours before I began testing. If you expect to experience similar temperatures you are about to see in the following graphs, you need to make sure you've done this, otherwise they will vary significantly. Before we look at the Cinebench test, let me remind you, I'll walk you through the graphs quickly, but you can pause the video at any time and study them at your own speed. Here are the Cinebench results. All the values in the graph are sorted from the lowest average temperature at the top to the highest average temperature at the bottom of the screen. Maximum temperatures represent the peak temperature during each run of the test, which might have occurred just for a few seconds, yet I found it interesting, so I left it in. On the left side from the graphs, you have combinations of the coolers with thermal compounds at a certain RPM. 1000 RPM has blue color and is always matched with 4.1 GHz CPU frequency, and 1200 RPM in black is always matched by 4.25 GHz on the CPU. If you're wondering whether 10 minutes was enough, let me assure you that you reach 70 degrees Celsius in about 20 seconds of the test, so that's really not an issue. Also, this is not a stability test, but a cooling test. Now to the result. Zalman CNPS20X with its original thermal compound takes the lead against Noctua in both categories. At 1000 RPM, it wins by 0.5 degrees Celsius, and at 1200 RPM by 1 degree Celsius. When the same thermal compounds are used, the difference is 0.2 degrees Celsius in favor of Noctua at 1000 RPM, but at 1200 RPM, Zalman takes the lead. The 0.2 degrees difference is so small that it's within the margin of error of this test, which was set right at 0.2 degrees Celsius. So the difference during this test at these conditions is immeasurable, which will show up in the final summary of the tests. So let's move to the Blender. In Blender, I use the Classroom module for the test. In the battle of solutions, Zalman takes the lead by 1.3 degrees Celsius at 1000 RPM and 0.9 degrees Celsius at 1200 RPM. With the normalized thermal compound, the difference is 0.1 degrees Celsius, which is within the margin of error, and 0.7 degrees Celsius at 1200 RPM, which makes the Zalman a winner. Now let's move to the most thermally difficult test, which is AIDA64 Extreme Stress Test. As you see, all the temperatures went up significantly. Zalman took the lead with its original thermal compound and beat Noctua by 2.4 degrees Celsius at 1000 RPM and by 2.1 degrees Celsius at 1200 RPM. In the normalized test, Zalman lead of 0.1 degrees Celsius is within the margin of error from Noctua, and at 1200 RPM, Zalman wins by 0.8 degrees Celsius. Just for the curiosity, have a look at the improvement Noctua fans could bring to Zalman if this combination existed in real life. It's 0.8 degrees Celsius at 1200 RPM. I wish I had more time and patience to withstand testing of more combinations, but I had to set a limit to be able to finish this video in reasonable time, so this is just what I did. Let's have a look at the last performance test, which is DaVinci Resolve rendering test. It clearly shows that real-life applications are not always as CPU intensive and don't produce as much heat as the synthetic ones. It also tells you that you can run an overclocked CPU using an air cooler. The trade-off would be the loss of single-thread performance because the frequency would be locked to your OC, and achieving 4.6 GHz all-core with air coolers is impossible. What's interesting is to see that if we wanted to get the best thermal performance with these two coolers, we would probably need to combine Zalman's heatsink with Noctua's fans and Zalman's ZM-STC8 thermal compound. It's time to have a look at the summary. In the normalized tests, where both coolers were using the same thermal compound, the difference between them when using fans at 1000 RPM was so small that it was within the margin of error, so I would call it a draw. At 1200 RPM, Zalman took the lead with temperatures which were lower on average by 0.57 degrees Celsius. In the test of solutions, where the original thermal compound was used with their brand's coolers, Zalman won both categories, being able to achieve temperatures which were on average 1.4 degrees Celsius lower at 1000 RPM and 1.33 degrees Celsius at 1200 RPM than Noctua. The test shows that when Zalman uses its ZM-STC8 thermal compound, it's able to achieve temperatures which are noticeably lower than Noctua by 1.37 degrees on average. In all tests, when the same thermal compounds are used, the difference between the cooler's performance is 0.20 degrees Celsius on average. Based on the result of this test, next time, if there is a next time, I'm doing the normalized tests using some more thermally conductive compound to be able to unlock the full potential of the coolers. Now it's time to have a look at the noise performance. You can pause the video to read the conditions of the test. If I sum it all up, everything in the room was silent except for the tested coolers. The sound tester was placed 50 centimeters or 19.685 inches from the test bench. It represents the worst case scenario where the user has a meshed PC case put on a table next to the monitor, which is next to their ears. The tester was always placed at the same three positions, left, right, and in front of the testing rig at the height of the middle of the heatsink, to find out which produces most amount of noise or whether there are any measurable differences. Let's move to the individual tests and start with 1000 RPM roundup. Here is a Zalman CNPS20X with two fans running at 1000 RPM. What's interesting is in this use case scenario that the noise levels are the same from all directions, which happened only once during the whole noise test. And now let's have a look at the same cooler but with Noctua fans running at 1000 RPM. Objectively, this combination improved the noise compared to the original fans by 0.5 decibels from left, 0.5 decibels from front, and 1.0 decibels from right. Now let's have a look at the Noctua NH-D15 SE-AM4 with two fans running at 1000 RPM. This was both subjectively and objectively the quietest combination of the cooler and fan speed in the whole test. My ears liked it a lot. Now it's time for the 1200 RPM roundup. Zalman CNPS20X with both original fans running at 1200 RPM. Subjectively, I'd use this cooler with these settings only in a well noise isolated case. In a meshed case, this would probably be too much, not only for me. And now the same scenario but with Noctua fans. For some reason, maybe the untidy wires started to play a role or something. This was subjectively the loudest combination, but it had the best thermal performance in the test. It would be worth trying to lower the RPM to 1100 and see what the temperatures and noise would be, maybe some other time. So let's move to the last test. The last is the Noctua NH-D15 SE-AM4 with both fans running at 1200 RPM. This is the quietest of the 1200 RPM roundup, yet I'd personally also try the 1100 RPM settings to create perfect balance between performance and noise. Now to the results. It's absolutely clear that Noctua won in all tests ranging from 0.4 to 3.4 dB depending on the test. Using Noctua fans on Zalman not only improves its thermal performance, as we know from the cooling test, but it also improves its noise performance. In the test of the solutions at 1000 RPM, Noctua cooler is on average 1.03 dB quieter than Zalman and 2.37 dB quieter at 1200 RPM. So if the noise is priority for you, Noctua is the way to go. Let's wrap it up and go for the final verdict. As you see, it's not going to be simple. Now that we know the results of the tests, and I assume you've seen both unboxing videos of the coolers on my channel featuring these coolers, we can answer the questions I introduced at the beginning of this video. So to the first question, is Zalman CNPS20X the best CPU cooler in the world, as it states on its box? Zalman won both the normalized and the solutions cooling tests, yet Noctua completely won the noise tests. If you win only in one category, can you be the best? Well, you can't. So that question is answered clearly. I'll address it in more detail at the very end. And now to the second question. Is what's inside this box, as a complete solution, able to deliver better performance than what's inside the other box? In other words, the battle of solutions. Thermally, the Zalman with its ZM-STC8 thermal compound offers better cooling performance on average by 1.37 degrees Celsius in all tests, and it increases its performance with higher load as seen in the AIDA64 stress test. So in this regard, Zalman is better. In the noise test, Noctua dominated and offers lower noise at the same RPM. If I give both coolers the same thermal compound, who's better? And by how much? If we give them both the same thermal compound, the thermal gap between both coolers narrows down to 0.57 degrees Celsius in favor of Zalman at 1200 RPM, But at 1000 RPM, it's difficult to pick the winner. They are tied at this RPM setting. Could Zalman's performance, both thermal and noise, be improved by using Noctua fans, or would it do just the opposite? Well, the answer is yes, it could. Both thermal and noise performance would be measurably better. Now to the last question. What makes the best air CPU cooler to be the best? Well, it's not just thermals and noise. There's more to it. While I was installing both these coolers, I noticed a couple of things. When I was installing Zalman, I noticed that I needed long enough Phillips head screwdriver and gloves, which are both required by the manual but are not provided in the package. Noctua provides this Phillips head screwdriver. When it comes to the installation of the heatsink, you need to make sure you install RAM modules ahead of installing Zalman, because it has so little clearance above them that you won't be able to do it afterwards. Also, if you install this heatsink, you won't be able to swap, exchange or add RAM modules after it's installed. You'll have to remove it. So this really needs to be taken into consideration. Noctua has this covered because it has these two cutouts on both sides of the heatsink. When it comes to thermal compounds, Zalman's ZM-STC8 has better thermal conductivity, but it uses aluminum oxide, which is electrically conductive, so you need to make sure you don't drop it anywhere on the motherboard, otherwise you might short something. Noctua's NTH1 is electrically non-conductive, so this is covered. When it comes to the installation, I noticed that it takes longer to install Zalman because you need to exchange the backplate under the socket. Noctua uses the original one. And I think I've covered everything, so I put together a list if you really want to have a holistic point of view at characteristics of both coolers, which has 10 priorities in it. They are my priorities and you may have different ones, so you may swap them based on your use case scenario. And before you make any purchase decisions, check them out and find out which fit your needs best. Now, I think that's really everything, so if you have any questions, let me know in the discussion below this video. I'll do my best to answer. And thank you for watching this video. I hope to see you next time.